Hello everyone. I hope you all are fine and doing well. So this is going to the fourth lecture of our video series, the generative deep learning. It is about the generative AI and deep learning. So we are combining both of the things to teach the machines to paint, write, compose, and play. Okay, so you haven't watched the previous three videos, and please go and watch. I hope you have watched it. If you haven't, then the link of the playlist is in description. Go and watch. Okay, the videos are very much interesting, and it is going to be very much interesting and hands hands-on learning experience. Okay, we are hoping to have if you really like this video, then please press the like button, because and I really need your support. Okay, please so the target of this video for the 10 likes. Okay, and please subscribe if you really like this video. So let's get back to the content. So we have this. So we have learned about the deep learning. Okay. If you we have learned about deep learning. What is deep learning? Deep learning is just a class of machine learning algorithm that used multiple stack of layers. Okay, it uses neural networks, the layers of neural networks to process the unstructured data. So what is unstructured data? So we have learned in the previous video as that there is a structured data and unstructured data. So what is structured data? Structured data that is structured, and unstructured data that is unstructured. So it is quite simple. Like videos are there, audios are there, text is there. So that is unstructured. Fine. So let's learn about what is the deep neural networks. So deep learning has now almost become the synonymous with deep neural networks. Okay, so it is something similar. Let's learn what is the neural network first. Then we will be getting understand. We'll be get understand what is the deep neural networks. So neural network is just the a stack of layers. It is just a stack of layers that contains unit that are connected to the previous layers. So I will say this. Just see this thing. This is one layer, this is second layer. So it one unit is connected to every unit. Okay, just see this thing. A is connected to B, and this and this. So what is happening actually? It is making a fully connected layer. Okay, so it is making a fully connected layer, and that is called the neural network. Okay, it is about networks of neurons, something like that, that similar to our brains, neural networks, if you have any idea about it. Okay, so so that is fully connected. Okay, so that's why that is called dense layer also. So the neural networks that are all adjacent layer fully connected are multi-layer perceptrons. Okay, so it has a new name, that multi-layer perceptron. Okay, I don't actually see any point much, but okay, let's call it multi-layer perceptrons. Okay, because it will be using the same word in the further book. Okay, fine. So what is forward pass? Forward pass is that with this connection, the previous input layer is passing some information to the next layer. Okay, and the this layer is passing to the next layer. So there is a forward pass. They just see that transformed by each layer in turn and known as forward pass. Okay, so you can just have a Google search more know more what is the forward pass. So okay, then like what is the magic of deep neural networks is finding the right set of weights for each layer in the most accurate prediction. So this is the main work, I will say. So you have to also focus on this thing, that finding the set of weights for each layer that the results in most accurate predictions. Yeah. So this is finding the weights. Okay. For the every layer there is equation, and in that equation there are weights. So you can say now it is actually correcting the weights again and again. So how it happens actually? This is very basic machine learning. I hope you know about this. If you don't know about this, then go and watch videos on this thing, that how actually a neural network actually works. Okay, uh, you know, like the weights are getting trained. Okay, so uh, what happens that it gives a forward pass and then forward information. Just understand that it is giving a forward information. So after coming to the output, it calculates actually the error. Okay, that how much error is from the actual value. There are predicted value and there are actual value. So how much difference is in the actual value or in the predicted value. So the error in the prediction is then propagated backward through the network, adjusting each set of weights a small amount of. Okay, so let's understand that in any situation. Okay, uh, in any new situation, let's see this thing, like any new situation you work. Okay, uh, but when you do that particular work second time, then you have the knowledge that what the mistakes I should not repeat. Okay, so that is what is called the back propagation. Just see this thing, back propagation. It is quite important because each set of its a small amount in the direction that improves the prediction most significantly. So actually, it gives the feedback to the layers that that improve there, because we have trained once. So that is what the back propagation is. You can just have a Google search about it. um, okay, so now we'll be okay. Just you can just see this is the input layer, this is the output layer, and these are the hidden layers. Why it is hidden? Because it is in between. So we are just seeing the input and output, and the in between the layers, they are hidden, so that they are called hidden layers. Okay, so let's understand uh, the TensorFlow and Keras. What is TensorFlow and Keras? Okay, so TensorFlow is an open source Python library for machine learning. Okay, it is released by Google, of course, and there is PyTorch also, similar to that, but they have slightly different. In fact, there are a lot of differences in it, but they actually used in deep learning frameworks. Okay, so TensorFlow and PyTorch both are very much famous. So TensorFlow works on tensors. That is the very simple thing. In fact, Python also works on tensors. So, and it provides a low level functionality required to train neural networks. So with the TensorFlow, you can train the neural networks. You have seen the neural networks, that how there is a different layer. So you can train with the help of TensorFlow. We will see how you can train it. Okay. So let's see the Keras. Keras is a high level API for building the neural network. So TensorFlow is low level functionality, but Keras is a wrapper type thing, and it is high level. Okay, so built on the top of the TensorFlow, and it is extremely flexible, very user friendly, making it an ideal choice for getting started with deep learning. So TensorFlow and Keras, we are going to learn both. I'm going to start one more series of TensorFlow and Keras soon, and then you can get catch up from there. Okay. Um, so let's learn about the multi-layer perceptron. Okay, so what is multi-layer perceptron? I hope you got an idea from here. Wait, here. The neural networks where all adjacent layers are fully connected is a multi-layer uh, perceptron. So this is called the multi-layer perceptron or a neural network. That is the very simple thing. Okay. So let's see. Okay. So now we have gone through a lot of theory part. Okay, So let's come to the practical part, that how actually it works, how we can make multi-layer perceptron actually. So guys, um, if you really like this video, please click the like button, and yes, and share this to the people who are really interested. So guys, we are going to hands-on learning on the data. Okay, so on the deep learning we are going to make a um, a model or a multi-perceptron layer, multi-layer perceptron. So we are going to make the neural networks for the first time. So let's do this. There is, like, doing anything, you need data. Okay, so we have the cipher data set. So what is the cipher data set? Just see this thing. It is loading actually. Wait if it is loading or not. Okay, yeah. So they just see that cipher data is a subset of the 80 million tiny images dataset. Okay, so this is quite famous dataset. I think consists of 60,000. Wait, cipher 10 dataset has okay, so has 60,000. So for the cipher 10 dataset there is 60,000 and 32 multiplied by 32 pixels color images and 10 classes. What are the classes? Just see this thing. Classes are airplane, automobile, bird, cat, bear, deer, truck. Okay, so this is the image dataset, and we are going to work on it. Okay, so let's do. Okay, just see this thing. The information is given here already. So here's the code. Okay, you don't need to, do a lot of manipulation. You have to just copy paste the codes. And I will say no, that try to write the codes. Okay, try to write the code, but for the demonstration purpose and just making the video like less time consuming, I am going to just copy paste the things. But whenever I watch the tutorials, I also write the codes with my hand, because you will get practiced of it. So let's copy this thing. Okay, that you just import the important libraries. Okay, so let's first I will just write it MLP. Okay, so I'm also making the GitHub repo for this, so that you can go there, and if you want anything, you can just search sorry you can just go and uh, experience the codes, that what are the codes are there, and you can get it from there. Okay, so link is in the description. You can get it from there. So it is actually connected. Now I will zoom it for you. Wait, I hope you are having a look on this. So I will just zoom it for you. So there is a NumPy and TensorFlow library already come up with this collab. So let's load the Cipher dataset. Uh, so I'm going to load the Cipher datasets, because in the Keras library, the dataset, there is Cipher dataset already there, so you can just download it from there. So it is calling the Keras dataset, and from the dataset there is Cipher 10, so it is loading the data. I hope you got it now. So there are number of classes is equal to 10. We have defined it. So let's define it, and then we will be doing a training data set and testing data set. That is quite important. I hope that you have learned machine learning before, because uh, yeah, like, it is not going to be very much basic. It is going like, it is very required that you should have some knowledge of machine learning. And I will just catch up from there. Okay, I will I will say I will tell you that how to do this. Okay, so we just copy paste the things. You don't need to think much because there is x train, x test, y train, y test. So we are just making it. Okay, like just see this thing in the y training. There are y train, comma num classes. So they are making it categorical. Okay, it is quite important to make it categorical because y is, x is the pictures and y is the labels. So actually it is getting the labels. Okay, so they just see, we are doing the one hot encoding. So what is one hot encoding? I just want you to show one hot encoding. So one hot encoding is a powerful technique to treat categorical data. Okay, so there are 10 categories in our data. So it is handling that. Okay, so we don't need to think much in this thing. Just go here and build the model. Okay, so let's see some theory more, that how to build the model. So in the keras you will get two type of actually model building. uh, that is a sequential model, and I think there is one more, I think functional API, something like that. So we'll see. So sequential model is, it will define the every layer. So you will be get familiar with every layer in the sequential model. So this is sequential. You are getting it from the word itself that it is sequential. So let's copy this code and paste it here. Just see that from the TensorFlow.keras they are importing the layers and models, and a model is called to models. From the models they are importing the sequential, and there is a layers. Just see, it is the first layer, input layer, and it is defining the shape 32 multiplied by 32 multiplied by 3. Like, 32 and 32 is what? So it is actually the image size. I hope that you had focused on the how 32 and 32 multiply by 32 uh, pictures are there, that was given here. Just see this thing. Wait. So in the introduction, there are 32 multiplied by 32 pixel colors. So actually, it comes to the picture pixels. So and when it is a RGB color, na, we have to write that this three. Okay, because red, green, blue, all three are there. So in the dense layer, there is 200 neurons, and in the second layer there is 150, and after that 10. So why it is 10 at the last? So we are giving the input from here. uh, okay, but output is 10. Why output is 10? It is because that we have 10 categorical data. There are 10 classes that need to be predicted. So I hope you got it. So let's run it. Okay, so we have run it. Okay, so let's go. So after running this thing, you know so wait a minute. There are two ways. Like there is a sequential API, there is a functional API. So from the functional API, you can do the things, similar things. But let's do the things with sequential API so that you can see every layer, what every layer is working. Okay. So just see this thing. Uh, okay. So there are activation functions. That what is ReLU functions is there, sigmoid and softmax. Just see this thing. There are the activation function ReLU for softmax. So let's search about it, that what is the ReLU activation function. So I always appreciate this thing, that search on the Google that what it is. So it is actually the rectified linear unit. It's a popular activation function that is known as ramp function. Okay, so leave that. So what it does actually, why ReLU is used actually? Just see this thing. You know, ReLU ReLU is used for the speeding up. Okay, so there is a one thing, that introduces non-linearity. What is non-linearity? Actually, it omits the negative values. Every negative value we have, it will just make it zero. Okay, and it will not touch the positive values. I hope you got understand. Like if there is a -1, then it will just do it zero. Okay, so that is the ReLU function. What is softmax function? Just see this thing. So you will tell me that what is softmax function is going to be in the comments. So if you really want to learn, be active, search on the Google what is the softmax function, put in the comments. Okay, so there are a lot more things. So you can just see this thing. ReLU is it is making zero. Leaky is like it is going to be negative, and sigmoid is this. Sigmoid is something like SF, and this equation is there. Okay, you can just have some focus on that. But yeah, for this time now, you don't need to know very much about that. So they have made this tens units activation is ReLU. So these are the things. Okay. So let's have a summary of the model. So we'll just write it model dot summary. I hope okay. So it will generate the summary of the model. Just see the model is sequential, layer type. There are flattened layer. Okay, so this is output shape actually. And after that, this is the first layer. It is going to be the dense layer. 200 layers are there. Then there are 150 layers, and after that, output layer is 10. Okay, the total parameters are 6 lakh 42 46,260. Okay, and trainable parameters are there and non-true. So this is the summary of the model we made from here. Okay, so this is the model. Fine. So we excited that we are making a new model here, and it is our going to be the first model. That is something like hello world in the machine learning. So we'll just copy this thing that how to compile a model. So let's compile the model, and we will see what is the optimizers. Okay, and we will also train the model, evaluate the model. So let's do it. Okay, so we'll just put it and okay. So we have compiled the models. So what does it mean actually? So let's see here. What does it mean? So we have here compiling the model. We compile the model with an optimizer with a loss function and a logs function. So what does that mean actually? Just see this thing that we have defined a learning rate. There is a rate that how much step a model will go to iterate itself. I know it seems somewhat technical, but I will just say that in this one video we can't take everything up. Okay, so if you really want to know about it, then you can first you can comment if you really don't know about it, or you can just search on the Google. So fine. I hope that you know it, but you can search on the Google. You can have a course of interview NG. You can just watch the basic machine learning from there also. Fine. So optimizers are there. Adam is the one optimizer, and then we have set up the learning rate. So its learning rate is 0.005. So we usually keep the learning rate low so that it can learn the gradually. It will not skip the things. And there is a loss function that is categorical cross entropy. Okay, optimizer is op ठीक है, optimizers we have this Adam optimizer we are using. So what is loss function actually? So first thing it is loss function is something that you just predict, you predict the values with the neural networks. So in the predicted values and the actual values, you compare, and how much loss is there, that is actually the loss, that how much it is lagging. So there are mean square loss error. There are a lot of errors like you can just see this thing. This is the ground truth, that this is the truth value. Y1 is truth value and P1 is Pi is predicted value. So we have just negative it, square it, and then divide by the total. So we have added the total. We have taken average. Okay. So there are mean square also. So we'll see that. Like we have, like I hope that you have already studied that. So let's see the optimizer function. What is the optimizer? Optimizer and algorithm. Okay. Uh, so that used to update the weight. Optimizer actually the update the weights in the neural networks based on the gradient of the loss function. Okay, so actually, what is ADAM? What is ADAM? ADAM is the adaptive moment estimation. I will tell that please download this book on the internet. You'll easily get. You just write the generative deep learning PDF, or you can just go on a website libregen.rs. From there you can download any of the books. Okay, so there are a lot of optimizers you can see here. So let's train our model first. So for the training our model, we just copy this thing, and I will tell you that what all things are there. Okay, so for the training thing, you just need to say that fit the model. Okay, fit the model. So fit what we are fitting, X train we are fitting, Y train. So we are just training our model, and batch size is 32. So we will be giving the input in a chunk size, that this is 32, uh, you can say 32, uh, like there are 32 images in a one packet. Okay, something like that. And epoch are 10. Epoch is something like 10 times it will train, I think. And shuffle, of course shuffle is true because it will be getting randomized. So let's do it. So just see this thing. It is actually training the neural networks, and accuracy is getting better here. So in the 10 times it will getting more and more better. Here's only 0.33. It means that 33% we are correct. Now it is getting 40%. Now it is getting more and more. So let's see. So this is things. The X train and Y train is our training thing. There is batch size and then epoch and then shuffle. Okay. So just see this thing. It is quite very good documentation, I will say. Good book, that there are raw images. The second is that one hot encoded class labels. That every image, X-train is about image and Y-train is about labels. Okay, so actually it is training. It is training the model, and after that we'll evaluate that it is doing good or not, because we have made the model. So how much it is going to be the accurate. So that's what we are going to do. So just this thing, see this thing, it is actually training and now it is accurate almost 50-60%. It is okay for now that we are training this model for the 50, 60, 81, but we'll be making it more accurate. So actually we are getting an idea of deep learning. Okay, that what it is actually, and we'll just evaluate the model. What we are evaluating? We are evaluating the X test and Y test. That what it will do. That it will predict the values on the X test. Okay, there will be some images. It will predict the value, and it will match up with the Y test. That to how many values Y test is matching. So that what give us the accuracy factor. So let's see. It is doing some manipulation. So, so just I will say just copy this pictures. Sorry, copy this code and paste it. Okay. So what we are doing, that viewing the predictions. So we'll be viewing the predictions. So here is almost 50%. 50% accuracy is there, 0.49. So just multiply by 100. So you'll get the percentage. So just see this thing. This is going to be the classes we are defining. And now we will predict. Now you'll see in a picture. Okay, okay, wait. Oh, we'll wait. So I know this video is getting longer, but we need actually more time for that. So this is matplotlib to show that show the images. Okay, so the data set. So just see this thing. Okay, just see. There is a truck, and actually it is a ship. Okay, so predicted is truck. So just see this thing. Predicted is cat, and actually this is cat. Okay, so in this picture, there's predicted airplane, but actually it is deer. So that is quite blurry data set. So many times the accuracy is low on cipher data set. But yeah, we will see in the further uh, videos. So this was all, and congratulations to everyone that you have made your first deep learning. Um, and I hope that if you are watching this video for the generative deep learning, then I hope that this will be not your first uh, deep learning model, but it is okay if it is first, because you have to start from anywhere at least. So I hope that you loved this video and got the concept. What we have done actually, we have made a model. Okay, so we have trained some neural networks. So basically, I was focus on this thing, that we are focusing on this thing, that of making a neural network and actually training it to get predictions. So this was all it for this video. If you really like this video, please like and subscribe this, share to the people who really required it. And thank you so much for uh, listening me, and meet you in the next video. Bye bye.